To evaluate this integral, we've got sine squared and cosine squared. Since both of those are even, what we need to do is use the double angle formulas, which are here on the formula sheet. We've got this formula for sine squared and this one for cosine squared. So I'm going to rewrite this as integral of 16 times sine squared is replaced with 1/2 1 minus cosine 2x. Cosine squared is replaced with 1/2 times 1 plus cosine 2x. And now, let's see, the 1/2 times 1/2 times 16 gives us a 4. And then if I multiply this together with that, I have to FOIL it. So 1 times 1 is 1. Then I get plus cosine 2x. Then minus cosine 2x. And then when I multiply these two together, I get minus cosine squared 2x. Of course, these two terms in the middle cancel. So we've got 4 times the integral of 1 minus cosine squared 2x dx. Now I have to use the double angle formula again to replace this cosine squared. So cosine squared of 2x gets replaced with 1/2 times 1 plus cosine of 2 times 2x dx. Where does this extra 2 come from? Well, up here we had cosine of squared of x, and so that wound up getting replaced with with the formula cosine of 2x. This is twice what this x was. So down here, when we use the formula again, we go from cosine squared of 2x to the formula with cosine of 2 times 2x. So if I distribute my half through there, I get 1 minus 1/2 minus 1/2 cosine 4x dx. I can combine these together and get 4 integral of 1 minus 1/2 is 1/2 minus 1/2 cosine 4x dx. And this is an integral that I can do easily. We get 4 times, integrate that, we get 1/2 x. Integrate this, we've got the 1/2 on the front. Cosine 4x, if I integrate cosine, I get positive sine of this. And I have to divide by 1/4, or I'm sorry, divide by 4. And get this, add c. And distribute that 4 through there, I get 2x minus 1/2 sine 4x plus c.